Assalamu alaikum dear students. Welcome to nuclear physics lecture. In today's lecture we will talk about 1D Graph Accelerators. I am Dr. Pervez Ahmed. So 1D Graph Accelerator is being developed by 1D Graph in 1931. This kind of accelerator can provide a beam of higher energy than the single stage accelerators. The tandem the tandem 1D Graph accelerator can produce 20 mega electron volt protons and 30 mega electron volt alpha particle. I mean that's the capability of 1D Graph accelerator. So 1D Graph accelerator can also accelerate electron and positive ion of the higher charges. So how the 1D Graph accelerator look like? I mean here you can see it's a internal structures of 1D Graph accelerators. I mean different part. You can see it here in this particular figures. I mean it's all the parts. They are being labels. They are being labels and they are being denoted by their respective functioning. So what actually we have, this 1D Graph accelerator consists of a rapidly moving belt. I mean this is you can see it here, the yellow color. It's a rapidly moving belt. So what actually it do, this belt accumulates positive charge as it passes an array sharp spray points. I mean it's basically the function of this belt. I mean the yellow color here you can see it. So what actually it do, this moving belt accumulate positive charge and it passes an array of the sharp spray points. So what happened with this, it transports electrons from the belt to the spray point. So what actually happened then, the positive charge on the belt is continuously transferred by the moments of the belt away from the ground. I mean the moments, I mean as we mentioned, that this belt is continuously moving. So by this the positive charge on the belt is continuously transferred by its moments from the grounds. So at higher voltage terminal, I mean so you know that we have to apply the voltage. So at high voltage terminals, a hollow metal sphere, I mean here you can see this hollow metal sphere. So is another set of the spray point. Uh, I mean so the hollow metal sphere is, what is that, it's another set of the spray points. And what it do, it neutralizes the charge on the belt by electron emitted from the spray point. So what happened with this results in positive charge to the sphere. I mean here we result in positive charge in the sphere. So the continuous process of transferring the positive charge to the sphere can build a high potential on the sphere. I mean when we continuously transferring the positive charge to this particular locations, so what actually it results in a high potential on the sphere. So the limit of the high voltage that can be accumulated in the hollow electrode is determined by the discharge potential to the surrounding housing. I mean this is the way to limit the voltage, and this can be done by accumulate I mean by the process, that is the limit of the voltage that can be accumulated and the hollow electrode as determined by the discharge potential to the surrounding housing. I mean this is the surrounding housing. So if it is insulated by some pressurized gases, I mean if we have utilized some pressurized gases like nitrogen, carbon dioxide, sulfur hexafluoride, about 16 time mega electron by 16 megawatts can be achieved. I mean if the surrounding housing is insulated by some pressurized gases, about 16 megawatts can be achieved. I mean if we insulate this surrounding housing by these pressurized gases, so we can achieve 16 mega volt with this insulation. So this can be used to accelerate the protons. I mean, this voltage, this 16 megavolt, that we can achieve by simply by insulation with the pressurized gases. So this can be used to accelerate the proton to the energy of about 15 mega electron volt in a single stage. I mean, by insulation with the pressurized gases, we can get the voltage equal to 16 megavolt, and this 16 megawatt voltage can be used to accelerate electron with a kinetic energy equal to 15 mega electron volt in a single stage. So the energy of the beam, I mean, it's just like we mentioned on the previous slide, that we can accelerate a beam of the proton with the energy equal to 15 mega electron volt. So the energy of the beam produced by the Van de Graaff generator is extremely precise. I mean, this is one of the great quality. The How we can say that the advantage of the Van de Graaff accelerators. Similarly, the current which range from 10 to 100 microampere is less than that of the other accelerators. The beam current I is equal to Q capital INR is equal to EZ INR. We remember here by Q we mean the particle charge, and INR is the incident particles current. And here we say that the Z is basically the net charge of the beam particle. So this is all this very simple details about the Van de Graaff accelerator. This all for the Van de Graaff accelerator. See you in the next lecture.